Today we will be learning about absolute value inequalities. A few things to remember about inequalities. If it's less than or greater than, it has an open circle. And if it's less than or equal to or greater than or equal to, it has a closed circle. And this is when you're graphing. Absolute value inequalities have multiple solutions, and the answers can be represented both algebraically and graphically. We're going to be doing both of those today. There are two types of absolute value inequalities: conjunctions and disjunctions. We're going to talk more about those. So make sure you know those words today. Conjunctions are when the inequality is less than or equal to. So as you can see in the example, this is ax plus b, it's the absolute value of, is less than c. When you write it, it's actually going to be written as negative c is less than ax plus b, which is less than c. I'm going to explain the steps in just a moment. If you have the absolute value of ax plus b is less than or equal to c, if it's a conjunction, it will be negative c is less than or equal to ax plus b, which is less than or equal to c. Make sure to write down these steps because they will help you later. Step 1, isolate the absolute value. If necessary, you won't have to do that all of the time. Step 2, copy the basic inequality without the absolute value brackets. Step 3, write the additional inequality sign. Step 4, negate the c value. This creates a compound conjunction. Step 5, solve and graph. I'm going to show you an example now. This is just the rules or the steps for conjunctions. So our first example is the absolute value of x plus 1 is less than 3. So you should have your steps written, and we're going to follow those. So step 1, isolate the absolute value. Well, that's not necessary in this step because it already is isolated. Step 2, copy the basic inequality without the absolute value brackets. Okay, so I'm going to rewrite it. X plus 1 is less than 3. So that's step 2, copying the basic inequality without the absolute value brackets. Step 3, write the additional inequality sign. All right, so that's the additional inequality sign. Step 4, negate the c value. So our c value is 3. So I'm going to negate it. So it's going to be negative 3. So we get negative 3 is less than x plus 1 is less than 3. Again, we know that this is a conjunction because it's less than. So I'm going to write conjunction because it's a less than after we have isolated the absolute value. Now we are going to solve this. And by solving this, what we're going to do is we're going to subtract, we're going to work inside out. So we need to subtract 1 from all sides. So there should be 3 places that you're subtracting 1. So negative 3 minus 1 is negative 4. Still less than, this becomes a 0, so we have an x in here, which is less than 2. Now we have something that we can actually graph. So I'm going to write my number line, or draw my number line. I'll write it, draw it. Start with 0 in the middle. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, negative 5. Okay, so our x is less than 2 and our x is greater than -4. So you're reading from the inside out. So x is less than 2. So I'm going to go to 2, 1, 2. And it's a open circle because it's not less than or equal to. It's just less than. So it's less than 2. And x is greater than -4. So 1, 2, 3, 4. Right here. It's greater than -4. So many times you're going to see it drawn like this. It'll be colored in to show that it's between -4 and 2. So here are a few things to remember for conjunctions. For conjunctions, we generally shade in between the 2 points. That's, again, it's generally, so it's not always, but generally shade in between the 2 points. Remember, you must isolate the absolute value before you set up the compound inequality. So a conjunction is also known as a compound inequality. And the last thing, when multiplying or dividing by a negative, you must switch the inequality sign. So don't forget that. The rules still apply. Just because it looks a little different does not mean that it doesn't apply. Example number 2. The absolute value of -x minus 5 is less than or equal to 7. So I first want to look at, okay, it's less than, so that's a conjunction. And if it's a conjunction, I need to follow the steps. Step 1, isolate the absolute value if necessary. Well, it's already isolated, so I don't need to worry about that. Step 2, copy the basic inequality without the absolute value brackets. Okay, -x minus 5 is less than or equal to 7. Step 3, write the additional inequality sign. Okay, there's my less than or equal to. Step 4, negate the c value. So there's my -7. This creates a compound conjunction. Now, step 5, solve and graph. Okay, so I'm going to work from the inside. I'm going to add 5 to all sides. So I get -2 is less than or equal to -x, which is less than or equal to 12. All right, I have a negative inside, so that means I need to divide by a negative to all 3, which also means I need to change my signs. So I get x in the middle. This is going to change to a greater than or equal to. This is going to change to a greater than or equal to. And I get -12 on this side, and I get +2 on this side. So another way to write it to make it easier to graph is that it's -12 is less than or equal to x, which is less than or equal to 2. So my smaller number is going to be on the left and my larger number is going to be on the right. Now I'm going to graph it. Put my 0 in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So x is less than or equal to 2. 1, 2. And it's a closed circle. So it's less than or equal to. And x is greater than or equal to -12. So here's my -12, and it's greater than or equal to. So you can draw it like that, or you can draw it like that. Doesn't matter. And you're all done with that problem. So now let's talk a little bit about disjunctions. Disjunctions are when the inequality is greater than or equal to. This is different than conjunctions because either of the solutions can be true to satisfy the inequalities. So for example, if we have ax, the absolute value of ax plus b is greater than c, we're going to get ax plus b, or turn it into ax plus b is greater than c, or ax plus b is less than negative c. I'm going to talk about the steps in just a moment. And then the other example is if we have the absolute value of ax plus b is greater than or equal to c, then it will turn into ax plus b is greater than or equal to c, or ax plus b is less than or equal to negative c. So make sure to write down these steps to use later. Step 1, isolate the absolute value, if necessary. Step 2, copy the basic inequality without the absolute value brackets. Step 3, for the second inequality, switch the inequality sign and negate the c value. So for the second one, switch the inequality sign and negate the c value. So as you could see in the previous slide, that's what we did. Step 4, solve and graph. So example 3, the absolute value of x plus 3 is greater than or equal to 9. So since it's greater than or equal to, it's a disjunction. It's a disjunction, which means we need to split it up. So let's follow the rules like we did before. Step 1, isolate the absolute value if necessary. There's nothing to isolate. Step 2, copy the basic inequality without the absolute value brackets. So I have x plus 3 is greater than or equal to 9. I'm going to put a big or because that's disjunction. Step 3, for the second inequality, switch the inequality sign and negate the c value. So x plus 3 is less than or equal to negative 9. Now I need to solve. So I'm going to start with the first equation. I'm going to subtract 3 from both sides. And I get x is greater than or equal to 6. Or, let's do the other side, subtract 3. And I get x is less than or equal to negative 12. Okay, so now I'm going to graph the two inequalities. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Negative 12, positive 12, so at least I know where it's going to. Okay, x is greater than or equal to 6. So 1, 2, 3, 4, 5, 6. And it's greater than or equal to, so it's going to be a closed circle. And it's greater than or equal to. So kind of follow the way of the sign if you want to. That's how the arrows go. Just a little trick as long as the x is on this side. Okay, x is less than or equal to negative 12. So it's a closed circle and the arrow is facing this way. So that would be my final answer. So for disjunctions, we generally shade out from the 2 points. So again, there's that generally word. Not always, but generally, shade out from the 2 points, like you could see in the previous example. Remember, you must isolate the absolute value before you set up the two inequalities. That's going to help you figure out if it's a conjunction or a disjunction. Example 4. The absolute value of negative 4x plus 4 minus 1 is greater than 31. Okay, so my step 1 of both conjunctions and disjunctions is isolate the absolute value. We do need to isolate it in this case. So I'm going to add 1 to both sides. And I get negative 4x plus 4 is greater than 32. Okay, greater than tells me it is a disjunction. So I need to follow the rules of a disjunction. Okay. Step 2. Copy the basic inequality without the absolute value brackets. So negative 4x plus 4 is greater than 32. And it's a disjunction, so I'm going to put an or. And step 3 is for the second inequality, switch the inequality sign and negate the c value. So negative 4x plus 4 is less than negative 32. Now I'm going to solve each inequality. So subtract 4, and I get negative 4x is greater than 28. Divide by negative 4. Okay, so I'm dividing by a negative. So I get x is less than negative 7. Or, let's solve the other one. Subtract 4 from both sides. Get negative 4x is less than negative 36. Oops, sorry. 36. Divide both sides by a negative 4. So I get x is greater than 9. Now I am going to graph my inequalities. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so x is less than negative 7. 1, 2, 3, 4, 5, 6. And it's an open circle, and it's less than, the arrow is going that way. And x is greater than 9. It's 1 before 10. My arrow goes that way. And there, I'm done. So now I have a few practice problems. I encourage you to pause the video and try these on your own and then check your answers afterwards. So I have 4 problems today. First problem is the absolute value of 2x minus 5 is less than 11. Okay, the less than tells me that it's a conjunction. So I'm going to go back and I'm going to look at my conjunction steps. So we already looked to see, I isolated it. It was already isolated. So now step 2, copy the basic inequality without the absolute value brackets. So 2x minus 5 is less than 11. And then I'm going to copy it and negate it. Add 5 to all of them. So I get negative 6 is less than 2x is less than 16. And then divide everything by 2. Get negative 3 is less than x, which is less than 8. And then graph it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So x is greater than negative 3. 1, 2, 3. It's open circle. And it's greater than negative 3. and x is less than 8. It's an open circle, and it's less than. That's it for problem 1. Problem number 2. The absolute value of negative x minus 2 is greater than 2. Okay, greater than tells me it's a disjunction. So, for a disjunction, I need to copy the basic inequality without the absolute value brackets. And a disjunction is the or. So it's negative x minus 2 is greater than 2, or negative x minus 2 is less than negative 2. So I'm going to add 2 to both sides. Get negative x is greater than 4. Divide by negative 1. I need to change the sign of the inequality. So x is less than negative 4. Now on this side, I'm going to add 2 to both sides. I get negative x is less than 0. Divide by a negative. So I get x is greater than 0. Do my graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So x is less than negative 4. There's my negative 4. X is less than negative 4. And x is greater than 0. And there's problem number 2. Problem number 3. The absolute value of 2x minus 10 minus 4 is less than or equal to negative 2. So I need to isolate the absolute value. So I'm going to add 4. So I get the absolute value of 2x minus 10 is less than or equal to 2. Okay, less than tells me that it is a conjunction. So I'm going to first rewrite it. 2x minus 10 is less than or equal to 2. And it's less than or equal, well, it's greater than or equal to negative 2. So now, solve. I'm going to add 10, add 10, add 10. So I get 8 is less than or equal to 2x, which is less than or equal to 12. Divide everything by 2. And I get 4 is less than or equal to x, which is less than or equal to 6. Graph it. And these are both positive numbers, so I'm going to have my 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 4. X is greater than or equal to 4. 1, 2, 3, 4. So it's a closed circle. And x is greater than or equal to. And x is less than or equal to 6. So fill that in. And there we go. Problem number 4, our last practice problem. The absolute value of x minus 5 plus 4 is greater than or equal to 10. So first, I need to isolate the absolute value. So subtract 4 from both sides, and I get x minus 5 is greater than or equal to 6. And my greater than or equal to tells me that it is a disjunction. So it's a disjunction. So I'm going to write my two inequalities. So I get x minus 5 is greater than or equal to 6, or x minus 5 is less than or equal to negative 6. Add 5, and I get x is greater than or equal to 11, or plus 5, and get x is less than or equal to negative 1. So now I'm going to graph it. One, two, three, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so x is greater than or equal to 11. So it's a filled in circle. And it's greater than or equal to, because that's the way my arrow's facing. And x is less than or equal to negative 1. Here's my negative 1. My arrow's facing that way, so I'm going to go that way. That's all for today. We'll see you in class.